Hello, welcome to my chemistry review number 3. We have been talking about bonding, especially ionic bonding. But before continuing in that, I wanted to go to some important theory called Lewis theory, proposed by a great scientist called G.N. Lewis in early 1900. This theory is very important to understand various types of bonding. There are 4 important facts in that. Number 1, it says electrons in the outermost shell involved in bonding. And number 2, as we saw in my review number 2, electrons are transferred from one atom to the other to make ionic bonding. Number 3, electrons are shared to make covalent bonds. Number 4, electrons are transferred or shared in order to achieve stable inert gas configurations. Usually 8 electrons or an octet. So these are rough periodic table. Now there's a special way to draw these Lewis structures proposed by G.N. Lewis. Now if you look at the element silicon, we know it has 14 protons and 14 electrons. So let's see how the electrons are arranged around the nucleus. 2 in the first shell, 8 in the second shell, and 4 in the outermost shell. So Lewis proposed a special way to put these outermost electrons around the atom. You put one here, 2, 3, and 4 like that around the atom, so that the negatively charged electrons will have minimum repulsion. So let's see, chlorine, it has 7 in the outermost shell. So this is the way of drawing it. Start with the 1, 2, 3, 4, and then we go back 5, 6, 7. Sodium is in group 1, so it has only 1 electron. We can show it like this, 1 electron. So keeping in mind, let's go to look at our ionic bonding story. Ionic bonding, transfer of electrons to complete the octet. So using Lewis symbols, these are called Lewis symbols. So sodium has 1 electron. Here I have put a cross to represent the electron, to distinguish between the electrons of sodium and chlorine. So you can see chlorine here, 1, 2, 3, 4, 5, 6. And I wanted to keep this place empty because sodium is giving an electron to the chlorine atom. And the net result is sodium lost an electron. As you saw in my review number 2, it becomes a sodium ion. Sodium ion. And chlorine gain an electron. It becomes chloride ion. So you can see this electron obtained from sodium. So that is your sodium chloride formula unit. Now let's see some more examples. Let's see how to make barium oxide. Barium is in group 2, so it has 2 electrons in the outermost shell. And oxygen, 1, 2, 3, 4. I put 5 and 6 here because I want to keep this place empty for the electrons to come from barium. And then you end up with barium lost 2 electrons, so it became barium 2 plus. Oxygen atom gained 2 electrons, so it became 2 minus. And without showing charges, we just call it BaO or barium oxide. This is the chemical formula for barium oxide. Even last time we saw in a different way how magnesium chloride is formed. Now you can see clearly magnesium atom can give one electron to one chlorine atom and the other electron to another chlorine atom. So since magnesium lost 2 electrons, it becomes magnesium 2 plus, and these 2 chlorine atoms become 2 chloride ions. That means MgCl2. It is the chemical formula because 2 chlorine atoms are involved. Aluminum oxide. Let's see how aluminum oxide is formed. We need 2 aluminum atoms and 3 oxygen atoms. See, 2 electrons from this atom comes to this oxygen atom, and these 2 electrons come to this oxygen atom. These 2 electrons come to this oxygen atom. So we end up, since aluminium lost 3 electrons, it becomes aluminium 3 plus, 2 of them. Each one is 3 plus charge. 3 oxygen atoms become 3 O2 minus atoms. So again, without charges, we can say Al2O3. Now, how did you know in the first place that 2 aluminum atoms and 3 oxygen atoms are needed to make aluminum oxide? You can use a method called Crisscross method. So our compound is going to be formed with aluminum and oxygen. Aluminum is in group 3. Therefore, we know that it is going to make a stable 3 plus ion. Oxygen has 6 electrons in the outermost shell, so it is going to gain 2 electrons. So it's going to be O2 minus. So we do a cross like this, and then write Al here, O here, and these 3 coming down here, 2 going down there. So our formula is going to be Al2O3. Now we are going to see covalent bonding. Share electrons to achieve noble gas configuration separately. Let's see the hydrogen molecule first. Each hydrogen atom has 1 electron in their outermost shell. So they keep them in the middle, and we call it sharing electrons. So when they share, each atom assume that it has 2 electrons. So this atom can feel 2 electrons, and then we cover this one. The other atom also can feel 2 electrons. Without writing the 2 electrons, we can just write a line like this. So this line is called the covalent bond between the 2 atoms. So always remember, one line represents 2 electrons. Now let's see the chlorine molecule, Cl2. So these are our Lewis symbols for chlorine atoms. So these 2 electrons will be shared between them here. And again, let's cover one atom. Now this atom feels that it has 8 electrons in the outermost shell. If you cover this atom feels that it has 8 electrons in the outermost shell. So again, we have a Cl-Cl bond, that is a chlorine molecule. Same thing with hydrogen chloride molecule. They make a bond and you get HCl molecule. How about the water molecule? Again, you can see that oxygen has 6 electrons. I wanted to make this place and this place empty so that it can share with H2 atoms and make the water molecule, H2O. Now the last two examples, nitrogen and oxygen. Nitrogen atom has 5 electrons in the outermost shell, and I want to draw the Lewis symbols like this: 1, 2, 3, 4, and fifth one I put here because I want to keep this place empty so that they can share the 2 electrons. But now you can see this is not correct, because if you cover one N atom, you will count only 1, 2, 3, 4, 5, 6 electrons only. There are 2 electrons in the bond. So we are not making the octets. Therefore, we have to bring 2 more electrons from this side and another 2 from this side, so that it will make a triple bond. Now if you count, this nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 octet. Same with this one. 1, 2, 3, 4, 5, 6, 7, 8. So it's a stable molecule, nitrogen gas. Now let's see finally the oxygen molecule. 1, 2, 3, 4, 5, 6. These two will join together, share together to make our O2 molecule. But again, the number of electrons will not be complete like in nitrogen. Therefore, these 2 electrons also have to be shared, as in this one. So now we have 8 and 8. But I want to tell you finally, this is not the final structure, because when you go to advanced studies you will see that this is not perfectly correct. But you will see that later in later lessons. And one more thing before I finish. How did you know that in case of nitrogen, you are going to have 3 bonds between them? Those days we used to draw these figures like this. Nitrogen 5 electrons, and we take 5 and then count from 5, 6, 7, 8. 3 more electrons are needed to make the octet. Therefore we draw 3 electrons in the middle like this and 2 left. And the next nitrogen atom, again 5, we put 5 electrons in the outermost shell, and 5, 6, 7, 8. So we need 3 more. So we have to put 3 electrons in the middle and 2 left. So now we can see between nitrogen and nitrogen there's a triple bond, and 2 electrons are remaining with each other. So in my next lesson we will see more about isotopes, and that time we will be talking about neutrons in the nucleus. After that I will be directly going to chemical calculations, the mole concept and all that thing. So thank you for watching.